Assalamu alaikum. Once again, welcome to my YouTube channel, and through the platform of MS Lectures, I will be demonstrating you about the very important topic of the physiology, which is the cardiac cycle. So what is actually the cardiac cycle? Cardiac cycle actually consists of the events which occurs during the one complete heartbeat. So what are those events? Those events consist of the different phases like atrial systole. After atrial systole, it is followed by the ventricular systole. After ventricular systole, the phase of the ejection comes, and ejection is further divided into the rapid ventricular ejection and the slow ventricular ejection. And after slow ventricular ejection, the another phase which comes, it is the ventricular repolarization, in which the ventricles actually relax. And after this, the final phase, it is the rapid filling phase. So these are the phases which are actually involved in the one cardiac cycle, and these events happen during the one complete heartbeat. So we will start by the atrial systole. So what happens during the atrial systole? During the atrial systole, atria actually contract by receiving the electrical impulse from the SA node that is situated at the top of the atrium. So by receiving the electrical impulse from that SA node, atria actually contract and then propels the blood from the atria towards the ventricle. So during this, what happens that the duration of this atrial systole, it is actually the 0.1 second, and during this, atrioventricular valves are open to allow the blood to flow from the atrium inside the ventricles, and during this, semilunar valves are closed. So furthermore, if you talk about the wave which is formed, so during this, P wave is formed. Why? Because atrioventricular valves are open during this phase, and this is actually the systolic phase. So this atrial systole is followed by the formation of P wave. So after discussing the features of the atrial systole, now we will discuss the next phase, which is the ventricular systole phase. So ventricular systole phase, it is the second phase which is followed by the atrial systole. So its duration is 0.05 seconds, and during this, the AV valves are actually closed, and semilunar valves are also closed. So both valves are actually closed during the ventricular systole phase, and the ventricles are fully filled with the blood. So in this phase, what happens that ventricles prepare themselves for contraction and to propel the blood into the whole systemic circulation and the circulation which is known as the pulmonary circulation. So after the discussing the ventricular systole, now we will discuss the ejection phase. So what happens during the ejection phase? AV valves are closed in order to prevent the backflow of the blood from the ventricles towards the atrium, and during this, both atria are actually relaxing, but ventricles are actually in the systole phase, they are actually contracting. So the pressure inside the ventricles is very much high. So next phase, it is actually the ejection phase. So what happens during the ejection phase? Both atria are now relaxing, AV valves is now closed in order to prevent the backflow of blood from the ventricles back towards the atrium, and the ventricles are contracting. So the pressure inside the ventricles is very much high. Because the ventricles contract, the blood is forced to, you can say, propel out from the ventricles towards the aorta, towards the systemic circulation, and towards the pulmonary circulation. So in this case, the pressure inside the ventricles forces the semilunar valves to open, and then the blood moves out of the aorta. And furthermore, the ejection phase consists of the further two phases. We have the rapid ventricular phase, and then we have the slow ventricular phase. So what are the events which are located inside the rapid ventricular phase and the slow ventricular phase, we will discuss now. So after discussing the phase of the ejection, now we will discuss about its subtypes. So first of all, we have the rapid ventricular phase, and then we have the slow ventricular phase. So during the rapid ventricular phase, what happens that the amount of blood flow from the ventricles to the aorta due to the pressure gradient that actually develops between the aorta and the ventricles. So the amount of blood which actually flows from the ventricles towards the aorta is known as the stroke volume. So stroke volume is the whole amount of blood which flow from the ventricles towards the aorta due to the pressure gradient. Because we know that in the ventricles are actually contracting, so that's why the pressure inside the ventricles is very much high. So that's why that pressure actually forces the blood to move out from the ventricles and to flow towards the aorta. So this actually completes our rapid ventricular phase. So in the slow ventricular phase, what happens that we know that now whole stroke volume is now shifted from the ventricles to the aorta and through the whole systemic circulation. So now the amount of blood in the ventricle is very much low. So small amount of blood slowly, you can say, flow from the ventricles towards the aorta. So that's why it is termed as the slow ventricular phase. And during this and after this phase, what happens that this phase is actually followed by the T wave, which we will discuss later. So we've discussed in the ejection phase that whole blood has propelled out from the ventricles towards the aorta, and after this phase we have the ventricular diastole. Now the whole blood has gone towards the aorta. The whole stroke volume is now shifted from the ventricles to the aorta, and now and we know that during the phase of the ejection the ventricles were contracted, and there was the depolarization phase during which the electrical impulses were flowing from the AV node. Now what happens that repolarization phase of ventricles starts during the ventricular diastole, and the ventricles again relaxes, and what happens that the actually semilunar valves are now closed, because the blood is now no more flowing from the ventricles towards the aorta due to the difference in the pressure gradient, which is actually which has actually vanished. So due to the finishing of the pressure gradient difference, what happens that the blood flow from the ventricles towards the aorta has now stopped, and followed by the semilunar valves closed. Now I will talk about the love dub sound. So first sound which we heard during the heartbeat, that is after the closure of the atrioventricular valve after the atrial systole, and the second sound which we heard of, which we hear actually, which is after the closing of the semilunar valves, and that is the dub sound. So this completes our ventricular diastole phase. And now rapid filling phase. Now again the cycle starts, and what happens that the atria are now contracted and ventricles are now relaxed. So blood flow from the atria towards the ventricles, and the third sound is actually heard during this process, which is normal in the case of children, but it is abnormal in the case of the adults. And after this, there is a term which is known as the diastasis, which is referred as the slow filling the blood from the atria towards the ventricles. At the end, I will like to draw the pattern, ECG pattern, which is often observed during the ECG. So this is the whole pattern. This is the P wave. This is the QRS complex, and this is the T wave. So this phase which we observe, this P wave is actually demonstrating us the atrial systole. After this line is referring as the ventricular systole phase. This QRS complex is denoted as the ejection phase, and after this is referring as this T wave is referring as the phase during which the repolarization of the ventricle occurs. So repolarization of ventricle occurs, after which the semilunar valves are closed, and again the cycle restarts, and the atria are contracted and the ventricles are relaxed. So the blood again flows from the atria towards the ventricles, and the cycle continues to proceed on. So I've discussed the whole events of the cardiac cycle in this lecture, and hope you have understood it well. Last but not the least, don't forget to subscribe my honest lectures. Thank you.